Hi everyone, in this video we would be designing a rate limiter, which is one of the very popular question asked in Atlassian interview round. So let's get started. Now let's try to understand what is a rate limiter and why do we need that. So now let's assume that you are practicing one of the problems on Leetcode, and for that you have already written the solution. Okay, now you are going to press this run button. So once you press this run button, several APIs will be triggered. So let's try to analyze all those APIs. So as you can see, the first API which was triggered is this interpret solution. So in this API, what essentially you are doing is you are sending 4 parameters to the backend. The first one is the test cases. Second is the language. Third is the question ID. And the fourth one is the code which you have written. So all these things would be sent to the backend, and backend will start executing the code. So now let's try to understand this with the help of diagram. So once you call this interpret solution API, the backend is going to start execution of that code which you have returned over here. But the problem is that code will obviously take 2 to 3 seconds. You cannot block the front end for 2 to 3 seconds. So what this backend will do is it will create the unique submission ID and it will immediately return that submission ID to the front end. Okay. And when the submission ID is returned to the front end, the code is still being executed in the back end, right? So how would this front end know whether the code is executed or not? Or even what is the output of that code, whether it is wrong or accepted or TLE or MLE, right? So in order to know that, this front end uses HTTP polling. That is, it will keep on calling this check API again and again until it will receive the output. So here you can see that run button has called this check API 4 times. The first time when it called this check API, the server responded state as pending, meaning that server has not yet started the execution of that code. Okay. The second time also the status is pending. The third time is also it is pending. But the fourth time, as you can see, the status or the state is accepted, indicating that the code is executed. Okay. And it also returns the status message, whether it is accepted or wrong answer or whatever. So currently it is accepted, so it will return accepted. Okay. So the point that I want to highlight over here is, even if you click on this run button a single time, then also there are many APIs which are triggered. So just imagine if I try to spam this run button, what will happen? So it will obviously increase the load on this server, isn't it? And on top of that, let's assume that I write one script which will do that job on behalf of me. So obviously that script will keep on hitting this API again and again, and it will bring the server down. And let's say I am Leetcode. So obviously I don't want my server to go down. I don't want any user to spam this run button. So I will try to protect my server or APIs. So in order to protect my server, I will introduce something called as rate limiter. So let me show you that Leetcode also uses this rate limiter. So let's say I try to spam this button. That is, I try to click on this button again and again. So this is the first time I'm clicking. This is second time. This is third time. But as you see, once I clicked on this button third time, it is saying that you are submitting too frequently. And it is asking me to subscribe to the premium subscription. Okay. So here you can see that this interpret solution API is returning me this error, which is rate limited. So Leetcode also tries to protect their server with the help of this rate limiter. All right. Now, one thing that you need to understand about this rate limiter is rate limiter has two main things. The first one is the time window, and the second one is the number of requests which you can make in that time window. So let's assume that Leetcode wants you to only request 6 times in entire day. So the time window would be this, and number of requests would be this. It means that if you try to hit the run API 7th time or 8th time or 9th time, then it will be rate limited. That is, it will not even reach the server. So this is how the configurations would be present in the rate limiter. So I hope now you understood what is the rate limiter and why do we require a rate limiter. And we also saw the real world use case. So now let's check out the requirement with LLD interview perspective. The requirement is quite simple to understand. The first one is you need to rate limit the users based on their ID and their tier. So if they have a free subscription, in that case, the rate limit configuration should be very tight. For example, you should only allow 2 requests in 10 seconds. And if the user has a premium subscription, in that case, the configuration should be very loose. For example, you can allow 10 requests in 10 seconds. Okay, so this is the first point. The second requirement is we should have 4 different types of rate limiters. The first one is token bucket, second is fixed window, third is sliding window log, and the fourth one is sliding window counter. And the design should be extensible. That is, in future, if I want to add a fifth type of rate limiter, then I can easily do so without even modifying the existing code. And the third requirement is our rate limiter should be thread safe, because we don't want any type of inaccuracies in our rate limiter. Okay. And it should also be efficient, because let's assume that your API which you have made only takes 200 milliseconds, but your rate limiter takes 2 seconds. So overall, when the client clicks the button, it will take 2.2 seconds, which is obviously bad, right? So it means that your rate limiter should be as efficient as possible so that your overall response time remains as less as possible. Now that we have understood the requirements, let's check out the class diagram of rate limiter. So for that, let's begin with the user class. So in the user class, we have 2 attributes on which we have to rate limit the user. The first one is the user ID and the second one is the tier. Okay. So in our application, currently there are 2 tiers. The first one is the free user and the second one is the premium user. Similarly, you can also add the third one, which is premium plus user. Okay. Now coming to the rate limiter service. So overall, what will happen is when the client calls the API, it will first reach out to this rate limiter service and call allow request function of this service. So if the user is a free user, in that case, the request would be redirected to rate limiter, which is used for free users. And if the user is a premium user, in that case, the request would be redirected to second rate limiter, which is used for premium users. Okay. So basically we would be using 2 rate limiters. The first one would be for free users, second one for the premium users. So for that, we are using this hash map. Okay. So as you can see, we have segregated the rate limiter based on the user tier. All right. So here we would be having if else logic, which would redirect the request to one of those rate limiter based on the tier of the user. And coming to the rate limiter, as we have already known, rate limiter would be having the configuration. And in the configuration, we have already seen that we would have 2 things. The first one would be the time window, and the second one would be the max request which we can make in that time window. Okay. And rate limiter will also have the underlying algorithm. So for that, what I've done is I have made this rate limiter class as abstract, and this is one abstract function which will take user ID as the input. And there would be 4 different classes like token bucket, fixed window, etc. And all of them would be overriding this function, allow request function. Okay, so all the logic for the rate limiting would be present in this respective classes. All right. And since we are having lots of different classes or lots of types, what we can do is we can use factory design pattern. In the factory design pattern, we would be having a centralized logic for creating the objects, isn't it? So we would be storing that logic into this particular class. All right. Now let's try to understand the entire flow once again. So the client will try to call the API. All right. That request will first reach to this rate limiter service. It will call the allow request function of this service. All right. And there we would check the tier of the user. If the tier is free, then the request will go to the rate limiter 1, else it would go to the rate limiter 2. Okay. Why two rate limiters? Because rate limiter 1 would be having some tight configuration and the rate limiter 2 would be having some loose configuration. All right. So I hope you understood now. And the request will basically go to one of this classes. Okay. It will not go to this class because it is one abstract class. So under the hood, we would be using one of this classes. So let's say for free user, we are using fixed window rate limiter, but for premium user, we are using token bucket rate limiter. Okay. So essentially for both of those users, we could have different types and different configuration. So finally, this classes would be rate limiting the user based on the user ID. And if the user is eligible to make the request, in that case, the request would be redirected to the server. Else the class, the respective function would be returning 429 error, which we already saw in the Leetcode, right? So I hope now you understood the entire class diagram and the flow. Now let's see all the different types of rate limiters one by one. So let's start with the fixed window rate limiter. So over here, we would be having fixed windows, which you can see over here. So this gray colored boxes are the fixed windows and the duration of this windows is 1 day, that is 24 hours. And the maximum number of requests which you can make in this window is 6. Okay. So let's assume that this is Monday, this is Tuesday, Wednesday, Thursday, etc. And you are trying to request 100 times on Monday. Then only first 6 requests would be redirected to the server and all the other requests would be rate limited. And now let's assume that you want to make a successful request. So in that case, you have to wait for a new day, that is Tuesday. So on the Tuesday, you can again request 6 times. The moment you request 7th time, it will be rejected. Okay. So again, if you want to make successful request, then in that case, you have to wait for Wednesday and so on and so forth. So this is how the fixed window rate limiter works. Now let's try to visualize this thing. So here's the animation for the fixed window rate limiter. So over here, we can see that the window is of 24-hour and you can at max request 6 times in that window. So this is the window. This gray colored box is the window. So let's try to request 6 times. The moment I request 7th time, it is getting rejected, as you can see over here, isn't it? So I hope now you understood the fixed window rate limiter. And one more thing that I want to highlight is this fixed window rate limiter also has this particular disadvantage. That is, if you try to request at the end of the day and at the start of new day, then you can have 2x the traffic, as you can see over here. So within this short duration, you are able to request 12 times, isn't it? So that's the disadvantage which is present in this fixed window. But I hope now you are cleared with the fixed window rate limiter. Okay. Now let's see the sliding window log rate limiter. So in this particular rate limiter, we would be having a sliding window which would keep on rolling like this, and the duration of that window would be obviously 24 hours, and the number of requests which you can make in that window will be 6 requests at maximum. All right. It means that it would only accept 6 requests. The moment you try to request one more time, it would be rejected. So over here, it got rejected because it already had 6 requests, 6 green dots. And as I already told you that this particular window will keep on rolling. So the moment the first green dot goes out of the left side of this window, you can again make a successful request. Why? Because one successful request has been reduced and the window only had 5 successful requests. So that's the reason why the request which you made just now got accepted. Okay. So I hope now you understood the sliding window log rate limiter as well. And this particular rate limiter prevents the disadvantage which we saw in the fixed window rate limiter. Why? Because if you want to request one more time, then in that case you have to wait for the sliding window to roll and move this particular request out of the left side, right? Then only you can make one more request. So in that case you cannot ever have 2x the traffic. All right, but obviously this sliding window log rate limiter has its own disadvantage, which is it needs to store all the successful requests in a queue, so that if this particular window reaches over here, it can pop out the first successful request out of the queue, right? So for each user, it would be storing all the successful requests made in one day. So obviously this is not memory efficient, and hence this is the disadvantage of the sliding window log rate limiter. So I hope now you understood what is sliding window log rate limiter, the advantage of this rate limiter over fixed window rate limiter, and the disadvantage of this rate limiter. All right. Now the third rate limiter is the token bucket rate limiter. So over here, when a user tries to call any API, the request will first go to the rate limiter. Here the rate limiter will first check whether the tokens are available in the bucket or not. If tokens are available, in that case, it would reduce one token and send the request to the server. If let's say the bucket was empty, in that case, the request would have been rejected. All right. In this rate limiter, you need to remember two main things. The first one is you cannot have infinite number of tokens into the bucket. The maximum number of tokens into the bucket would be equivalent to the maximum number of requests which you can make in this window. All right. And the second point in this token bucket rate limiter is it would also have the refill rate. So refill rate is nothing but window upon request. That is 24 hours upon 6, which is 4. It means that after every 4 hours, one token would be refilled into this bucket. All right. So let's say currently the bucket have only 2 tokens. So it means that after every 4 hours, I'll be getting one token into this bucket like this. So after first 4 hours, I'll get this token. After 8 hours, I'll get this token. Then after 12 hours, this token, and so on and so forth. All right. So this was all about token bucket rate limiter. Now let's try to understand this thing with the help of animation. So here we would be having one bucket, and that bucket would have total of 6 tokens. Now if I try to call the API, so for each request, one token would be utilized. So let's try to see that. So as you can see, I've requested several times, and for each request, one token got utilized. And you also saw that after some duration, one token got refilled, right? And that duration was 4 hours. Why? Because the window size is 24 hours and total number of tokens which this bucket can have is 6. So 24 hour upon 6 is 4. So after every 4 hours, one token was getting refilled, right? So if I try to again hit this API, then you can see after 6 hits, all the requests were getting rejected because we were not having enough tokens. But after that, some tokens were getting refilled after every 4 hours. So I hope now you understood the token bucket rate limiter as well. Now let's see the code. So this is the rate limiter service. In this rate limiter service, we will be having multiple rate limiters based on the user tier. So the first one is for the free user and the second one is for the premium user. For the free user, we are using token bucket rate limiter, and the configuration would be something like this, wherein we are saying that we should only allow 10 requests per minute if the user is a free user. And if the user is a premium user, then the configuration would be 100 requests per minute. And we are using fixed window rate limiter for the premium user. All right. Coming to the allow request function, this function would be taking the user object, and over here we'll be deciding to which rate limiter we have to forward this request. So we would be first getting the user tier, and based on that we would be forwarding the request to the appropriate rate limiter. Now let's check out the different types of rate limiters. So the first one is the token bucket rate limiter. So in the token bucket rate limiter, we have two different hash maps. The first one is for storing the tokens. So over here, what we are doing is for each user, we have their respective bucket, and that bucket would be having several tokens. So this hash map has the key, which represents the user ID, and the value, which represents the total number of tokens which are currently present in the bucket. And this hash map represents the last refill time of their bucket. So for example, as we saw in the animation, the token was getting refilled after every 4 hours, right? So once the token get refilled, we would be updating the time. So over here, the user ID would be present as the key, and we would be also storing the timestamp when the token was added into the bucket. Okay. Now coming to the allow request function. So before checking this allow request function, let's first try to understand one thing. So let's say there are two users, user 1 and user 2. So is there any need to synchronize both of those user? Obviously not. Why? Because both of this user would have their own entries into this hash map. So they would not lead to any race condition. But if we have simultaneous requests from the same user, then in that case we have to synchronize that request, right? So for that, what I've done is I've used concurrent hash map so that I can synchronize the operation based on the user ID. So that's what I've done. I've tried to synchronize the operation based on the user ID using this compute function. So if two requests are coming from the same user, then both of them would be executed one by one. All right. So in this function, first thing that I'm doing is I am refilling the tokens into the bucket. So let's see this refill tokens function. So in order to understand that, let's try to understand this thing first. So assume that this represents the timestamps, and let's say the last time when the user requested was at time is equals to 2, and currently the time is equals to 14 when the user is again requesting. So the total number of seconds which has been elapsed is around 12 seconds, right? And for the free users, the refill rate would be something like window upon maximum request, which would be 60 upon 10, which would be 6, indicating that after every 6 seconds, one token would be refilled into the bucket. So in order to know how many tokens would be refilled between the last request and the current request, what we would do is we would take 14 minus 2, which is 12, and divide that by 6, which is equals to 2. So between 2 and 14, total 2 tokens would be refilled. So that's what I've calculated over here. And once I get the total number of tokens which would have been refilled till now, I am just adding that refill tokens to the current tokens. Okay. And we should also make sure that it should not exceed the maximum number of tokens which could go into the bucket. All right. And we are also updating the last refill time if total number of refill tokens were greater than 0. And finally, we are returning the current updated tokens. So once we get the current updated tokens over here, we'll check whether the current token is greater than 0 or not. If it is greater than 0, then obviously we can allow that request to reach the server. So in that case, we'll reduce that current token by 1. Else, we'll not reduce that current token. Okay. So when we are reducing that current token to 1, what I'm doing is I am updating this Boolean variable indicating that the request was allowed to reach the server. So if this variable was true, then in that case, this allow request function would return true, else it would return false, indicating that the request was not allowed. Now, one doubt that you can have is why exactly I'm using this atomic Boolean variable instead of a normal Boolean variable. So let's try to use a normal Boolean variable. Okay. So now I have used this normal Boolean variable. So I need to update this part as well. But now if I try to hover over here, it is saying that variable used in lambda expression should be final or effectively final, right? So this is the lambda expression, and over here we cannot use something which is not final. So in order to do that, I have to either convert this to atomic Boolean, or second option is we can use array. Okay, why? Because see, when we try to use array which is final, all the values inside that can still be mutated, isn't it? So this is the second option. Both of the approaches will give the correct answer. So I hope now you understood the token bucket rate limiter. Now let's check out the sliding window log rate limiter. So over here, each and every user would have a queue data structure. This queue data structure would be storing the timestamps of the successful request. Okay. And again, I'm using this concurrent hash map so that I can synchronize the request based on the user ID. Now coming to this allow request function, the first thing that I'm doing is I'm noting the current time in seconds. All right. And then again, I'm using this synchronized kind of block based on the user ID. And over here, I'm trying to slide the window. That is, I'm trying to calculate the difference between the current time and the time which is present at the very left of the queue data structure. So if it is greater than the windows in seconds, then obviously we need to remove that. So I'll remove that using this poll function, and I'll keep on doing that until all the timestamps are within this window seconds. All right. And after that, I'll check the size of the queue. If it is less than the maximum number of requests which we can make, then obviously that request should be allowed to reach the server. So in that case, I am adding the timestamp into the queue data structure, and I am also updating this allowed variable. Okay. And finally, we are returning that. So this was sliding window log rate limiter. Now let's see the fixed window rate limiter. So in this rate limiter, we would be having two hash maps. The first one will be tracking the total number of requests which any user has made. So this particular key would represent the user ID, and this represents the total number of requests which that user has made in a specific window. And this hash map represents the window when the request was last made. So let's assume that your last request was made over a year. In that case, the key would be the user ID and the value would be this window. All right. It would represent the start of this window. Okay. Now coming to this allow request function, the first thing that I'm doing is I am noting down the window of the current request. So let's assume that the window of the current request is this. That is, you are requesting in this window. So obviously there was one transition, right? Last request was made over here, but the current request is over here. So in that case, what I'm doing is, first of all, obviously I am getting the last window from this hash map and I'm checking if it is equal or not equal. If it is not equal, in that case, we need to update the last window, because now the last window would be this, and we would also return one. So what this return one would do? Basically, it would go and update this particular request count hash map. So over here, it would say that earlier, whatever the number of requests you made in the last window, now remove all of them and now replace that by one, indicating that this user has only made one request in a specific window. Okay. So this was when the transition would happen. But let's say there was no transition. Let's say the last request was also in the same window. So in that case, obviously we would be just incrementing the counter. But we can only do so if the counter is less than the maximum number of requests which we can make in a specific window. Okay. And finally, we'll return the Boolean variable. So I hope now you understood all the three different rate limiters: token bucket, sliding window log, and fixed window rate limiter. Now let's see the output of the rate limiter. So this is the main class, and over here I've created the rate limiter service, and I've also created two users. The first one is the free user who can request 10 times in 60 seconds, and the second one is the premium user who can request 100 times in 60 seconds. All right. So first, the free user is going to request 15 times in 60 seconds. And then the premium user is going to request 120 times in 60 seconds. So let's see what would be the output. Let's run the code. So let's wait for the request made by the premium user. Then we'll try to understand the output. Okay. So first, free user is trying to make 15 requests. And as we already discussed, the free user is only allowed to make 10 requests in 60 seconds. So the first 10 requests were allowed, whereas the remaining 5 requests were blocked, right? And for the premium user, the first 100 requests should be allowed. So as you can see, the first 100 requests are allowed, whereas the remaining 20 requests has been blocked. Now, what we'll do is we'll try to also see whether our rate limiter is thread safe or not. So what I've done is I have written this function which basically tries to call the allow request function simultaneously 20 times. Okay, so call allow request function 20 times simultaneously. Okay, so let's try to run this particular function and check whether our code is thread safe or not. So for that, let's first comment out this code and use this particular function. And now let's run the code. Okay, now we can clearly see that total 20 requests were made, and out of them some of the requests has been allowed and some were blocked. So let's try to count how many requests were allowed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as you can see, out of 20 requests, only 10 requests were allowed. And by the way, this is a free user. So the configuration for free user was 10 requests in 60 seconds, right? So our rate limiter is thread safe as well because it is giving the right result. All right. So I hope now you understood all the different types of rate limiters and you also understood the output as well. So if you did, then please share this video with your friends and like this video as well. Thanks for watching.